Welcome to Unix lab. This is Karthik Mandani, your 14CS236. So today I'm going to do my lab experiment number 10 of Unix lab, that is interprocess communication using shared memory. So in this process, initially we made interprocess communication using pipe. Now we will make a interprocess communication through using shared memory. So both the process A and B will share the same memory. So it is known as shared memory and take the input from the same shared memory. We'll use the concept of pointers to implement the particular concept. So here we will use the concept of pointers, and there is a particular two processes program. So we'll use the interprocess communication. So this is a program A, in which first we will initialize a few header files and a few character variables and integer variables. So in the process A, we will ask the user to enter the key for shared memory. So the key will be taken as authentication for both the processes. So when the shared memory key will be stored in the variable key, this is a particular way to create a shared memory. So shared memory ID will be equal to shared memory get, that will be key comma 100, then IPC create is the interprocess communication create function, and we have given 0764 as a permission. Now we will print the shared memory ID, which will be given by this system call. Now SHM get is a system call which generates a shared memory and produces a integer variable, and if the variable is greater than 0, that means the shared memory is created. Otherwise, if the variable is less than 0, that means the shared memory is not created. So we have given the if condition. If the memory this particular value is less than 0, it will display that shared memory is not created. Now we are creating two pointers. One is virtual address, in which character pointer is created through shmat, and these arguments are passed. Next is string. So the string pointer is equals to virtual address. Initially we have made so that both of them points to a single memory that will be shared by both. So first we'll ask the user to enter the string and take the input and sleep and make the computer sleep for 15 minutes, and then the modified string will be the same, whatever the string he has entered. So this was process A, and now process B. So this is a particular code for process B. So in this we have included all the header files, and in this we will reverse and modify the string. So initially we are making a character reverse. We are making a structure in which we are making a pointer reverse and character A pointer, and in the integer counter, we are taking a integer variable as a counter and initializing it to 0 and initializing a variable I. Now while a counter that is not equal to null, that means while the index in the array A, having the index counter in the array A is not equal to null, we'll increment the value of counter, and same in the other way. Now in the process B, when process A is run, it is slept for 15 minutes. We have to run the process B, which will ask the enter key for shared memory. So initially when we have given the key for process A, that should be same for process B, which acts as authentication method between the shared memory of two processes. Now we will get the shared memory ID using shared memory get system call and giving this permission 100 and key as passing these as argument for the authentication. And if this particular value is greater than 0, that means the shared memory is less than 0, that means the shared memory is not created. If the particular value is less than 0, the shared memory is not created. Then we will initialize two virtual address and string character and make them again them equal, because they will be sharing the same shared memory which the process A and process B is sharing. Now this is a particular call for reversing the string. So we will receive this string and copy this string to the particular address and display the address. So this was my program, and the output of this particular program. So the output of this particular program is here. When we run the process A, I give here the authentication key as 12 and the shared memory is created. I will enter the string welcome, so it will tell us if it is received for process B. So this process is creating a string named welcome, which is going to a memory. That memory is also accessible by process B, which will, so this welcome will be received as a string from process B. So process B will access the string welcome. Now we'll ask the process B to enter the key. So the key should be same. So if the key has also entered 12, that means a shared memory is created. So the received string from process A is welcome. Now the process B is having the permission to manipulate the string, so here I've used the function of reverse, so it will modify the string and print the reverse of the string. So EMOCLEW, it will print the reverse of the string. This will be the modified string. So this was my program for in C++ for creating shared memory, the Unix last experiment number 10. Thanks for watching.